Alright, so I'm going to be doing, I'm going to be finding the limits. Again, this is Calculus 2, around chapter 6 of a full calculus book. For instance, like the James Stewart one that I'll be working from today. So we're going to find the limit as x approaches 0 of the function 1 minus 2x to the 1 over x power. Now, these in particular, you have to be careful because note that anytime you have an exponent or a variable in your exponent, chances are you're going to have to use natural log to get it down. So what I like to do is I like to say that y equals 1 minus 2x to the 1 over x power. Okay? And so what I'm going to do is I'm going to ln both sides. So ln y is equal to ln 1 minus 2x to the 1 over x power. Now that we have it ln, we can move this exponent this way. We're going to put this over here. And then we're going to rewrite it. Let's rewrite it. ln y is equal to 1 over x is the same thing as ln 1 minus 2x over x. That's the same thing. Now, we're finding the limit, right? We need to find the limit. So, we can write the limit right here, right? Don't ever forget your limit because it's very important to put the limit. So, we can write the limit right here. That's going to go right here. Limit as x approaches 0. It's going to go right there. So, ln y is equal to the limit as x approaches 0 of ln 1 minus 2x over x. Now when we plug in 0, what do we get? We get ln of 1 on top, which is 0. And when we plug in 0 in the denominator, we also get 0. So we can use L'Hospital's rule. Alright, so we're going to take the derivative of the top, which is, 1 minus 2x, you have to think of it as one whole number, right? So let's think of it as x. Well, what's the derivative of ln of x? Well, ln of x, and let's bring out our handy dandy whiteboard. We know that the derivative of ln x is equal to 1 over x multiplied by the derivative of what's inside right here. Okay? So when we take the derivative of ln of 1 minus x, we're going to take the derivative of 1 over, wait, let me explain that a little bit better if I don't skip any steps. So the derivative of ln 1 minus 2x is the derivative of ln 1 minus 2x multiplied by the derivative of what's inside. So we're going to put that in here, 1 minus 2x, right? So what is that? We're going to have, well, the derivative of ln x is 1 over x. 1 minus 2x is that number x. So this becomes 1 over 1 minus 2x multiplied by the derivative of what's inside. What's inside? Well, that's 0 because it's a constant. Minus 2x, the derivative of minus 2x, well, that's simply just going to be negative 2. So we're going to multiply that by negative 2. And here we have it on the top. ln y is equal to the limit as x approaches 0 of the derivative of that, which becomes negative 2 over 1 minus 2x, right? And that derivative, that is going to be over, what's the derivative of x? All right? The derivative of x, that's just 1. So you don't even have to write that 1. That's just 1. So that's nice. It just becomes negative 2, 1 minus 2x. Okay? So let's plug in 0 now for our x and see what happens after we use the L'Hospital's rule. Well, this is still negative 2. Let's see what our denominator is. 2 times 0 is 0. 1 minus 0 is 1. So let's write what we have left. So ln y is equal to negative 2, right? Don't forget the ln y. We ln'd both sides in order to take this exponent and bring it down. So we still have the ln y, but we want to find the limit as x approaches 0 of this function. Well, we need to get this function into just isolate the y. How do we isolate y? Well, we e both sides. You e both sides. Ln y is equal to e to the negative 2. Now what happens when it's e to the ln of something? Well, that just simply becomes that something, for a lack of a better word, right? E to the ln of y, well, that's just y. And if you don't know, look at my previous videos. I've proved that. So this becomes y is equal to e to the negative 2. So the limit as x approaches 0 for the function 1 minus 2x to the 1 over x power is e to the negative 2. Or 1 over e squared. And there you have it. If you have any questions, comment below. Hope that was helpful.